Hello and welcome. Hopefully this is going to make sense as I try to go over how to solve these equations using graphing. If you missed the previous lesson, we were solving by factoring. So as such, this expression is already factored on the left-hand side, and it would be able to be solved pretty easily, but I'm going to show you a new technique that involves using a graphing calculator. And let's go and get started. If we're going to use a graphing calculator, it only makes sense if we're going to have a function here. So I'm actually going to change the 0 to y so I can actually get it graphed. So what I'm going to be graphing is x plus 3 times x minus 2, but instead of equal to 0, I'm going to have it equal now to y. This is now a function that can be graphed, and that's what I'm going to do right now. The graphing calculator I'm going to be using is the Desmos instead of the TI-84 or something else. So this is pretty handy. I've got my Desmos calculator here on my phone. Reminder in class, please be only using the web-based version on your Chromebook. Do not be using your phone. So I'm going to go ahead and graph this out. Y equals x plus 3 times x minus 2. Now that I have that graphed, I'm going to go ahead and point out a few things that we've been interested in with graphs, such as the y-intercept and the vertex, but neither of which are actually what I'm concerned about right now. What I'm concerned about is where the y is actually 0, because remember, if you'll recall, 0 is y. So where is the y value 0? And it will always be on the x-axis. Now the answer to this problem, I can simply click where the graph intersects the x-axis and see my solutions for x that make sense here. X equals -3, because if I subtracted 3 from 0, and x equals +2, because if I added 2 to 0. So this is an alternative, but the upside here is that it's going to involve no work on paper. Everything can actually be handled in the calculator. Let's make a quick sketch of this on our notes. So just for this first problem, please sketch this on your notes where we graphed it and we found these x-intercepts of this would be +2, 0. And this will be -3, 0. So we are ready for our answers. X is equal to +2 or x is equal to -3. There's a few different ways you can present your answer, though. If you'll remember, usually on your multiple choices, they get presented as number sets. So they'll use these fancy looking little bracket things. And it doesn't matter which number you list first if that's the case. So these would be appropriate answers as well. Keep that in mind for any of these. All right, that's the core of what we're going to be doing today. This problem's done. So here's our next problem. Please remember to pause and take notes as you need to here. With this problem, it's already equal to 0, so I can go ahead and write down what my function is going to be that I'm going to use. So 0 becomes y. So y equals x squared minus 6x plus 8. And that's what I'm going to type in to my graphing calculator now. All right, there we go. And now I can tap on the zeros. Again, do not click on the vertex. The vertex here at 3, -1, I really don't care about. It is only the x-intercepts that I care about, which are also called zeros. So my answers are x equals 2 or x equals 4. So as a number set, we could list them out 2 and then 4, or 4 and then 2. And that's finished. The upside today is I'm going to expect to not see work, as I'm expecting you to use the calculator. All right, so here's the third one that I'm going to look at. There's 6 total problems I'm taking a look at with you. This one's a bit different though, because the zeros on the left-hand side, really that's not a big deal. But they did use the variable z, and that will mess some people up. So let's go ahead and talk about that. As far as what I'm going to graph here, I'm going to be graphing, again, change the 0 to a y. And my honest recommendation is to go ahead and change these z's to x's for when we're graphing. So that way it's guaranteed to graph. Now, in fact, if you're using the Desmos calculator, it can handle using a Z. If you want the Z, you can always press the little ABC right here and then have the whole alphabet available to you for when you're graphing, and it would actually handle it just fine, but I'm in a good habit of just always graphing with Y and X. All right, so here we go. I'm going to go ahead and get this graphed and take a look at it. Y equals x squared plus 6x. Always proofread what you're typing in. This one is a bit different, as the graph does go through 0, 0 in particular. So these are our two x-intercepts. You can see I didn't even move the screen down to see the vertex. It just doesn't matter. We're only interested in the x-intercepts. So you're only interested in the x value. So one of the x values is -6. The other one is 0. And this problem is finished. So -6 and 0. And we're done. You're never worried about the y values. The only thing the y values are there to do is tell you which values of x are the answer. So just the x values when you're looking at these. All right, so here's a different one yet again, because I'm going to show you the different situations that you might come across on each of these problems. The weird thing here is that you do not have a 0 on either side of the equation, so we're going to have to fix that. We could either subtract the two things on the left, or we could subtract the 14x that's on the right. I'm actually going to go with that. It's just a little bit less work of writing. So please take note on this, that you're going to want to always get it equal to 0 first before you continue with the problem. That's similar to when we were solving by factoring on the lesson before this. So I've now got x squared plus 24x minus 14x is equal to 0. And you know, I should go ahead and combine these like terms. I could have just gone ahead and done that. So x squared plus 10x is equal to 0. And yeah, now we're actually ready to go ahead and solve this one by graphing, as what I'm going to graph will be y equals x squared plus 10x. And I'm going to go ahead and grab my calculator. So y equals x squared plus 10x. Okay, with this one I do need to kind of zoom the graph out a little bit. I might also hide the keypad and zoom it out. We've worked a lot with this Desmos calculator by now, so you should be pretty comfortable with what I did just now. Alright, so the x values are -10 and we see 0 again. Not terribly uncommon for that to happen. So x is either equal to -10 or it's equal to 0. You might also see it listed with the 0 first. It really doesn't matter when you're writing out a number set. Alright, and that completes this problem. Hopefully everything's making sense. Please message me with email if it's not, or sign up for my Flex. We do have 2 more problems to look at real quick together. Alright, so another interesting thing is going to happen on this problem once we start solving. The first thing I'm going to do is just make a note of what I'm graphing. This is not a required part of work for you. I don't need you to show me what you're typing into the calculator, but I am making a mention of it here. It's already equal to 0, so I'm changing that to y, and I'm going to go ahead and write this down, but I am going to go ahead and make the change to x as far as that's concerned, just to make it more what I'm used to. Alright, now I'm going to grab my calculator and I'm going to type that in. And I missed my negative, so you always want to proofread what you're typing in as you go. It's easy to miss something. With factoring, I made a big deal that the x squared needs to be positive. That's not the case here. I didn't worry about that. I just went and typed it in. Now I'm going to take a look at what the answer is. And so what I'm now able to do is tap on it. Now, this is kind of weird. If ever this is the case where there's only one unique solution, you might want to actually zoom in on the graph and make sure that it's truly only one solution. There can be like a second one that's hidden as you zoom in a good bit, but this is it. This is called a double root when this happens. So the parabola comes up and the vertex is sitting on the x-axis. Let's go ahead and make a note about that you had your x-axis, it came up and intersected at exactly one place, which was -3, 0. And so your answer here would be that A is equal to -3, and that's specifically called a double root. Roots are the answers that we've been getting. So we always have two. Sometimes they are themselves. So that's what's happening here. A equals -3, A equals -3. For your solution set, it would just be written with the -3 in it, and that's it. All right, that leaves us with one last problem to take a look at. All right, so here's our final problem. 0 equals -x squared plus 6x minus 15. It's already equal to 0 conveniently enough. So what I'm going to do is, and remember, if it's ever not equal to 0, you need to work on it to get it equal to 0. So I'm going to go ahead and just type in the -x squared plus 6x minus 15. Some of you might be sitting there screaming in your heads, you didn't put the y equals. Well, honestly, that doesn't matter. If you type in the expression, the calculator assumes you're wanting its graph. So that's safe to do. All right, so this one's interesting, and this is the last one we're going to talk about. It actually never does actually intersect the x-axis. So I'm going to talk about what that answer means. Just make a sketch in your notes of the x-axis and show that the graph never did intersect it in this situation. What is our answer? Well, our answer would be that there are no real solutions. In other math classes and stuff, I don't see it much now, but you actually present that with the null set is what you would do for your number set. There are no real solutions. There's no place on the x-axis where the graph intersects it. Now, there are two complex solutions, but that will be coming later in the coming days as we talk about how to simplify those kinds of roots. If you've got any questions, again, please let me know. Thank you very much for watching this.